Okay, let's wrap up 4.5. Solve the following equations using logarithms. Now we're going to get into like the word problem form and some potential descriptions, but this is first a relatively easy situation. Solve the following equations involving logarithms. ln of e to the ln of x minus ln of x minus 3 equals the ln of 2. So we know that the ln e to the ln of x is just x. So the ln of x minus the ln of x minus 3 equals the ln of 2. Of course, subtraction becomes division. So the ln of x over x minus 3 equals the ln of 2. We raise e to both sides. We get x minus x over 3 equals 2. We can now multiply over, so x equals 2 times x minus 3, which means x equals 2x minus 6. Subtract 2x, we get negative x equals negative 6, which means x equals 6. Now, if we plug this in, we can see that 6 is going to be positive for both of these, so this is fine. The other one over here, let's see, ln of 4x plus 3 minus ln of x equals ln of 5. Same thing, it's going to be 4x plus 3 over x equals the ln of 5. And the ln's, by raising e to both powers, goes away. 4x plus 3 over x equals 5. Which means 4x plus 3 equals 5x. By multiplying the x over, subtract 4x to get x equals 3. Easy enough. So solve the following word problems. How much time will be needed for $27,000 to grow into $29,821.12 if deposited at a 5% interest rate compounded quarterly? Don't write around anything until the very end. So if we remember, A equals P times 1 plus R over N to the NT. They're asking when is $29,821.12 equal to $27,000 times 1 plus 0.05 over 4 to the 4t. So if we clean this up a little bit, 0.05 over 4 is 0.0125, so this is 1.0125 to the 4t, and t is our unknown. So now I'm going to take 29,000 and divide it, or 29,821, and divide it by the 27,000. And I'm going to leave a humongous number of decimal places just to be safe. This is only divided by 27,000. It says don't round to the end, but I'm going to round to like 6 decimal places. This is 1.104486. Now from here, if I wanted to get rid of the t out of the exponent, I could take the log of both sides. The log of 1.104486 equals the log of 1.0125 to the 4t, which allows me to bring the 4t out front. So 4t times the log of 1.0125. And now if I want t by itself, I divide by the 4 and by the log of 1.0125. So we get t equals log of 1.104486 over 4 times the log of 1.0125. And from here, it would be a calculator. So let's see, log of 1.104486 divided by 4 times the log of 1.0125. You get t equals 1.999998. Of course, we're rounding to the 100th. This is t equals 2. So all that to say, it takes exactly 2 years for this $27,000 to grow into $29,821.12. Now, what other kind of logarithm problems could we have? The number of tables, we'll go with tablets, which is what it's intended to be. The number of tablets that are sold in the US per year can be modeled by the function f of t equals 20.57 times the ln of t plus 10.58, where t is years since 2009. Estimate tablet sales in the year 2015. Well, this means t equals 6 because 2015 is 6 years since 2009. So f of 6 means I'm just plugging in 6. 20.57 times the ln of 6 plus 10.58. Now this is as far as you could go without a calculator, but if you had a calculator, you could plug it in. If this ends up on the test, this is literally all you would do. But if I plug this in, I get t, or f of 6 equals, we'll round to 3 decimal places, 47.436 million. We're assuming this is in millions. If the trend continues, in what year will tablet sales eclipse 60 million? So now 60 million, which we'll put on the left, 60 equals 20.57 times the ln of t, t is unknown, plus 10.58. From here, we'll subtract the 10.58 to get 49.42 equals 20.57 times the ln of t. Divide by the 20.57. And we'll go ahead and put this in the calculator, but you wouldn't have to if the numbers were nice. 29.42 divided by 20.57. We'll round to the 4 decimal places. This is 2.4025 equals the ln of t. And of course, to get rid of the ln, we'll raise e to both sides. So t equals e to the 2.4025 power. Now what is e to the 2.4025 power? It's 11.05. But what does that actually mean? It means it's 11.05 years since 2009. In this problem, though, we always round up, so we have to say t equals 12, because the next full year that we'll do it is 12 years from now. It won't quite happen at 11, but I have to add 12 to the 2009 in the problem, so the year 2021. And lastly, to find the inverse function, it's the same as we did in 4.1. We say y equals e to the 3x minus 1 plus 4. Switch positions, x equals e to the 3y minus 1 plus 4. Now we're solving for y. So we get x minus 4 equals e to the 3y minus 1. Take the ln of both sides. On the right side, the ln and the e cancel. So we end up with the ln of x minus 4 equals 3y minus 1. To get y by itself, add 1. So we get the ln of x minus 4 plus 1 equals 3y, and divide everything by 3. So then y is 1/3 times the ln of x minus 4 plus 1, or you could distribute it through. And of course, once you're done, y becomes f inverse of x. Is 1/3 times this thing, the ln of x minus 4 plus 1. So naturally, e and ln are inverse operations, so they are involved in inverse functions. And that is the end of 4.5 and the end of this chapter. And this is the last thing that will be on the next test. The next test will occur after the review.